Welcome back to our basic training on energy efficiency in building. Thank you that you're still with us. As we covered in the last session, what is energy and its units, now we are focusing on heat transfer and some energy terms. So let's start with heat transfer. Heat flow from one object to another. Whenever energy is out of the equilibrium with its surroundings, a potential exists for producing to change that. Following the second law of thermodynamics, it's spontaneously and minimized. So the heat flow goes from the hot to the cold, and this is one of the main areas which we will work particularly in the insulation, energy efficiency, and the refurbishment of buildings. So how is the heat transferred? So we have three different ways how the heat will be or is transferred. So I will start with the first one, which is the conduction. Conduction is the main form of heat transfer within solids. So when you give heat to an object, the kinetic energy of the atoms at the point increase and they move more rapidly. Atoms collide with each other randomly, and during this collision, they transfer some part of their energy. In this way, energy is transferred to the end of the object until it reaches the thermal balance. Second one is convection, is a common heat transfer in gases and liquids. Here, the molecular bonds are weak with respect to the solids. However, when you heat liquids or gaseous atoms, which again energy moves upwards since the density is less. All heated atoms move upward and cooler one sinks to the bottom. This circulation continues until the system reaches the thermal balance and we are back in the equilibrium. Heat transfer is quick with respect to conduction. And the last one is radiation is the method of heat transfer, which needs neither medium nor particles. It is a type of electromagnetic waves and shows the properties of waves like having speed of light and traveling in the straight line. In addition, it can travel also through vacuum, which is very important about the window issues, and glass, just like sunlight. Radiation meeting a surface can be reflected, absorbed, and transmitted. So you can see that here. That's also for later on for building paint, reflection of the paint. We will also talk about that one later on. So now we go to the energy terms. So we have primary. There are actually more than just this one, but these are the main one which we will work with. And that's primary energy, secondary energy, delivered energy, energy efficiency, energy conservation, renewable energy, which we have a full unit on it, and alternative energy. And I will come to each of them now. So primary energy is transformation to secondary, and no, sorry, the primary energy is the total energy content of the original resource. So primary fuels are fossil fuels such as coal, crude oil and natural gas, and renewable energy sources. Secondary energy, so it starts now with the transformation. So secondary energy is the energy contained in a fuel which results from a process such as manufacturing fuels, petroleum, diesel, etc., as well as secondary electricity. So it's the next one is delivered energy, is the energy content as received by the consumer. So that is actually the one in front of your kilowatt hour meter. So now, because this is one of our topics of our of our unit of our course, uh, well, the course is called Basics in Energy Efficiency in Buildings. Let's have a deeper look into that. So energy efficiency is a measure of effectiveness of a system that converts energy from one form to another. So energy input efficiency in percentage divided by 100 is output energy divided by input energy. So transformation of energy is always combined with losses. So they don't disappear, but they are transformed in some other forms. Let me see where I have a space here. Okay, I will go here. So this brings up the topic of energy efficiency. So energy efficiency is the amount of useful energy you get from a system. A perfect energy efficiency machine would change all energy, but in it is into useful work. However, a perfect energy machine 100% does not exist. So we have the energy input here. Then we have the energy. Then we have some losses. That might be heat, vibration, noise, and so on. And what the really useful energy is then here, the work. Good. Okay, so let's start. So one more slide, I think, or two more. Let's go for the energy conservation. So energy conservation, however, is the avoidance of use of energy that could be achieved by not even using energy at the first place, or due to reduction of energy via energy efficient appliance, or use of renewable energy source such as solar, gain from heating, etc. Then we have renewable energies, energy form which can be regenerated So in a nutshell, not fossil fuel based energy sources. And in correlation with the alternative energy to fossil fuel based energy sources, well, what I want to say is alternative energy is all the renewable energies except including the nuclear energy. I hope I was not too confusing there, and may I repeat that because I got confused there. Alternative energy to fossil fuel based energy sources, however, including nuclear energy, also all renewable energies, including nuclear energy. So now we come to the slide where we go really into the building now, and this will be then the last slide for this unit. Let me go out of the picture here now. Let me see where I have a space. No space here. Then we go on. No, that would be the wrong one. Let's go for that one. Good. So we have the primary energy here. Primary energy, this is actually like a kind of a recap that has not been transformed or been in conversion examples, uranium, oil, and coal. So this is just the pure energy, the raw energy. Then we have the primary energy transformed into secondary energy in power plants. The plant itself needs energy for operation and for transformation, and distribution losses occur. So we have here the secondary energy, but the losses are transformation and distribution losses, on-site use for pumping or cooling the towers or anything, and other uses. So these are the losses. And then we have a new term here which is called end energy. And I did not explain that before because this end energy or secondary energy has been transformed by conversion examples: electricity, gasoline, coke, mineral oil. So that is the energy which is transformed. So losses at the end user include combustion losses, distribution losses, transformation losses. These are these losses here at the end user, and this is the usable energy in the building then. Okay, so let me see if I forgot anything. No, that should be fine. It's a little bit confusing. You don't have to grab that at the first. I will come back to that with practical examples on building structures, and we will go more into the end energy, in the usable energy, and in delivered energy. So thank you very much for listening, and the next unit will be on renewable energy. Thank you very much.